Hi, Dan here. Welcome to the Fun Kids Science Weekly Reach for the Sky special, the podcast that explores the future of aviation, from the design and sustainability of future planes to the people who keep them flying and make sure our experience is top-notch. Aeroplane manufacturing is a truly global business, and the main builders are huge, from the mighty American Boeing Corporation to the huge Airbus. Other big names are Lockheed Martin, Embraer and Bombardier, and these five dominate both commercial and military aircraft production. In this podcast, we're meeting Airbus, who make a wide range of different planes for flying people and cargo around the world. Airbus was started in 1970. By some European countries to compete with Boeing. It's known for building amazing, cool, innovative aircraft like the popular A320, the huge Beluga, which we'll be meeting later, and not forgetting the A380, the world's largest double-decker passenger jet, which, get this, has a wingspan as long as a football pitch. It's just insane. Airbus has factories all across Europe, including here in the UK at Filton in Bristol and Broughton near Chester. Filton is a key hub for the research and development of all Airbus wings, as well as fuel systems and landing gear integration. Broughton is Airbus's primary manufacturing site for wings. It has a long history in aerospace, dating back to 1939. Aeroplane wings are crucial for flight, primarily generating the lift needed to counteract gravity and enable takeoff, flight and landing. They also play a vital role in stability and maneuverability through ailerons and flaps. So to start us off, here's Amy, giving us the background on wings and how they might look different in the future.
Amy Aviation. Reaching for the sky.
Hi, Amy Aviation here. Today, Zach and I are exploring one of the most important parts of an aircraft.
The snack trolley?
No, it's the wings. Now, you might have seen the huge Airbus A380, the largest passenger plane ever built, and thought that must have the largest wingspan. Well, they are large at 80 metres, but there's another plane with even bigger wings. That's the Stratolaunch Rock, and its 117-metre wings are longer than a football pitch. Now, we all know that planes need wings to help them fly, but while they look simple, they are anything but. For a start, they need to be incredibly strong to withstand the immense forces they encounter during takeoff, landing and flight.
Wings come in all shapes and sizes. Does that make a big difference?
Yes, long and narrow ones help planes glide through the air like paper planes you might have made. They're super fuel efficient, but not great at sharp turns. Then there's swept back ones. They're very good at supersonic speeds. That's when going faster than the speed of sound, but are no match when it comes to endurance. Wings also need to be very strong to give the aircraft lift and to support the engines that make planes move. Nature has had millions of years to develop and perfect things, and that includes wings. Biomimicry, that's biologically inspired engineering, is looking at some of nature's best designs to help solve technological challenges. An example of biomimicry is winglets. Those vertical wingtip extensions at the end of plane wings are inspired by shark dorsal fins. Yep, you heard me right. Sharks. Winglets significantly reduce a plane's drag, making them more fuel efficient. So next time you see a shark, say thanks for the smooth flight. Another example is by examining how birds fly.
Like the albatross, their massive wingspan helps them fly hundreds of kilometres without flapping. Talk about a natural-born pilot.
And guess what? Plane builders are taking notes from these winged wonders and asking if they can make plane wings more like bird wings. Longer, leaner and lighter means better aerodynamic performance, reducing fuel and carbon emissions.
But too long and wings won't fit into the airport. What's the solution?
Folding wings. Engineers are developing wings that fold up when aircraft are taxiing to the runway and unfold and lock before takeoff. Kind of like how birds tuck in their wings when they land. Clever, right?
I wish my shirts could fold themselves up.
Innovators are going a step further too. Airbus is investigating special sensors that can sense gusts of wind and adapt to them instantly. By working together, technologies are ensuring wings keep aircraft soaring for generations to come, with a little inspiration from the albatross, of course. Now, no one knows exactly what future wings may look like or how they might work. Maybe they'll bend or stretch or even change shape mid-flight like some sort of transformer plane. There's a wide range of careers behind aviation wings, from the aeronautical engineers and mechanics who design and maintain them, to the avionics engineer who specialise in the plane's electrical and electronic systems, and propulsion engineers who focus on the design and development of aircraft engines, which are often attached to the wings. So, next time you look up and see a plane in the sky, or you're looking out of a plane window, just think the humble wing is part of the process of innovation, imagination, and yes, even a little inspiration from nature, whether seagulls or sharks. Catch you again soon.
Amy Aviation, Reaching for the Sky. Created with support from a CAA Reach for the Sky Challenge grant. Find out more at funkidslive.com/Amy.
Thanks, Amy. Now, to find out more about the wings of the future, I met up with some people who are right at the cutting edge of plane and wing design. So come on, let's go meet the guys at Airbus. To get things off the ground, Sorry, it was a terrible pun. Could you introduce yourself and explain a bit more about what you do?
Yeah, hi, I'm Andy Reynolds, and I work at Airbus, and I'm an engineer there and a project manager. And I lead the team of people who are developing hydrogen systems for the Zero-E aircraft, which is an aircraft that we're developing to be a future commercial aircraft to take you on your holidays in a few years' time.
Could you briefly explain how that plane would differ to the planes we usually use to go on holiday at the moment?
So yeah, the big difference is that instead of having kerosene as the fuel to power you along, we'd be using hydrogen instead. And we're doing that because even though we work relentlessly to kind of make planes more and more fuel efficient and to produce less and less CO2, they still produce quite a lot. And we would like the planes of the future to not have any environmental, or certainly as little environmental impact as they possibly can have. And we're convinced that hydrogen can be a really fantastic way of achieving that. So that's why we're working on hydrogen.
Future fuels are very exciting, and it's amazing to think they'll have virtually no emissions in flight. So when designing planes of the future, what's some of the most exciting parts of the job?
Well, it's kind of fundamentally an exciting and interesting thing. Everyone lots of people love flying on planes, and they're interested in planes and are excited when they see them. When I sit on a plane and someone asks me what I do, then I love telling them I build the thing that you're sat on and that we're going on holiday together with inside. So it's really interesting because it's brand new technology. You're having to take stuff that is in labs and in science fiction almost and bring it into the reality. So you're really at the cutting edge of what is possible, and you're taking that and putting it onto a plane and making it so it becomes kind of normal. You're saying, here's some science that people are working on in universities and research institutes all around the world, and we're going to take that and we're going to put it into a plane so that you don't even notice when it's operating. We want to get it to the point where it's so normal that you don't realize that you're on a hydrogen plane. You just feel like you're on a plane. That's my job, is to take science things and put them into the real world onto planes so that you can go on your holidays and you don't think about there being hydrogen on board at all.
I imagine most people take the engineering and design, not to mention all the innovations, for granted. I imagine it's not a quick thing to design and produce a new plane, is it? Can you outline the design timeline?
So designing planes is really, really hard, and it takes a long time. So once we've got all the technology together and we know the plane that we want to build, then it can take about 5 or 6 years of work from having a kind of an idea of a plane and saying, yeah, we're going to go and do it, to having a plane that you can actually fly and leave an airport in. But we are a little bit ahead of that. So we haven't got to the stage yet where the technology is well enough understood. So we're still earlier in the process where we're trying to actually say, do we think that this can work in a real plane. So we've got a few years of work to do before we get to the stage where we say, okay, now we know the technology works, we can put it into this plane and we can start offering it to airlines and say, do you want one of these? Would you like to buy some off us? And we need the airlines to say, yep, that looks really cool. We would like to buy one. We would like to pay you this amount of money. And we know it's going to take this many people this far. And in 5 or 6 years, we'd like you to deliver us one. So that point where we start the sort of detailed design of the actual plane, even that is probably 5 or 10 years away. And my job is to get us to the point where we can actually do that.
So it's a really long process. What are some of the key differences between designing planes fueled by hydrogen compared to jet fuel?
The biggest difference, so if you're in a kerosene-powered aircraft, then the fuel is stored in the wings and under your seat in the bit between the wings. And unfortunately, when we're storing hydrogen, we want to store it as a liquid. And so it's not at kind of room temperature as the kerosene is, but it's at minus 250 degrees centigrade. So it's at 20 Kelvin, almost absolute zero. And to keep it that cold, we have to keep it in really special flasks, the sort of flasks that you would have your coffee in, with double walled and a vacuum in between the two walls. And they will be kind of big spheres or sort of sausage shaped tanks, and they'll have to be stored inside the fuselage. So instead of being in the wings, those tanks are going to be sitting at the back of the fuselage, just behind the rear door or behind the toilets, perhaps, that's at the back of the plane. And that means that we have to put those tanks on board, and then we have to get the fuel from those tanks to the engines. The engines will be on the wings as they are today. So we have to have special pipes that can take the very cold liquid hydrogen from the tanks out to the wings.
So the shape of planes is going to have to significantly change. What other things do you have to consider as part of the design process?
When you're designing a plane, you're kind of designing a little city, because you've got people in the fuselage who have to breathe and have to sort of keep warm and be entertained and be comfortable. And you have to create that space for them to fly in. So you're balancing many, many things. You've got the structure of the plane and how you actually lift it in the air, the aerodynamics of the plane. So how you make all the different compromises from all the different people who want different things within that plane. That's a really big challenge. When you start, the first thing you look at is how big do you want the plane to be? How far do you want it to fly? And what are the engines that are available to you? So the relationship between the plane and the engine is really important. And we're designing the planes in Airbus, but we work really close with the people who are making the engines, whether it's Rolls-Royce or GE or one of these big companies. And we're constantly talking to each other about what the engines of the future might look like and what the planes of the future might look like, so that we match the right engine with the right plane, and we design something that is able to take the right number of people as far as they want to go. Sometimes you want small planes if you're going to go on your holidays from the UK down to France or Spain or Italy. Sometimes you want a completely different type of plane, which is going to take you from London all the way over to Tokyo or to Los Angeles. So you need to understand that before you start designing the plane. What type of plane is it that I want to design, and what engines are available to me to match up with the aircraft?
And will hydrogen fuel planes be able to travel long distances, like today's jet fuel planes?
Probably not initially. The ones that we're starting to look at now will start with slightly smaller planes. So instead of this, an A320, which is the sort of thing that EasyJet or BA would be flying around Europe, that carries about 180 people. The planes that we're looking at are around 100 people and going about 1,000 nautical miles, which is about 2,000 kilometers. So they'll be able to fly around Europe or locally around the US, but they won't be able to go across the Atlantic or across the Pacific initially. So that's the thing we'll start with. As we get better at doing it, and as the systems get more efficient, we'll probably be able to make them a little bit bigger. But for really long range aircraft, the sort of thing that you'd fly from Paris to Beijing, you'll probably need to use sustainable aviation fuel in the future. So that's like the kerosene that we have today, but is made from sustainable products, and that will be the case probably for a very long time.
Okay, sounds like there's a compromise between using low-emission hydrogen, which can't go long distances, and other fuels that can take us further, but potentially at a greater cost. It's brilliant that the industry is looking to make as many elements as sustainable as possible.
Well, we believe that aviation is really important, and it's exciting, and people like flying. But actually, the ability to go around the world to learn about each other, to meet each other, to do business with each other, to go on holiday and understand different cultures in different parts of the world, we think is actually quite an important thing. And understanding each other and meeting each other is something that we want to be able to do. At the moment, there's still the majority of the people have never flown. And as people develop and become able to fly, a lot of people all around the world want to. And we don't see why they should be denied doing that. Whereas we fly a lot. But we don't want aviation to be damaging the environment. So the new fuels, whether it's hydrogen or whether it's sustainable aviation fuel, enable us to do all of the positive things that aviation allows, but without having the impact on the environment that currently we have.
When do you think we'll start seeing hydrogen-powered planes?
So we think that in the next sort of 10 to 15 years, we can have the technology ready. You need both the technology and the planes to be ready, and you need there to be enough low carbon hydrogen. So low carbon hydrogen doesn't really exist at the right quantities today, and we're working with governments and other industries, so big trucks and ferries, and maybe sort of the sort of things that you have in quarries. A lot of those machines as well, they can run on hydrogen. And we believe that hydrogen can become something that's quite a normal fuel, that in the same way that we don't think very much about there being gas coming into our homes to heat the homes or to run our cookers, that hydrogen can be as normal as that, become a commodity that's used in a lot of different industries. But that isn't the case today. So we need hydrogen to become available, and low carbon hydrogen as well. And then we need the planes to become available. We think we can probably get the plane available. It looks like a little bit ahead of when the hydrogen will be available.
Okay. All right. It would be really cool if you could briefly fly through the pros and cons, fly through, another pun, anyway, of sustainable aviation fuels, batteries and hydrogen.
So sustainable aviation fuel is a really important fuel that will be used a lot. It's already in the fuel that you pick up. If you're an aircraft at Heathrow or in any airport in the world, it will have a small amount of sustainable aviation fuel in. And all of our planes that we deliver, and in fact all of our planes that are in service already, can already use 50% sustainable aviation fuel. And they will be able to use 100% sustainable aviation fuel in 5 or 6 years' time, probably by the end of this decade. And that's really important because that enables us to dramatically reduce the carbon emissions of aviation, maybe by sort of 80% compared to today. So that will be a really important part. And as I say, even once hydrogen's available, sustainable aviation will still be the thing that you'll use for long distance travel. Today, it's quite expensive and there's not enough of it. So we need people to be producing more of it, which means governments and the people who make fuels need to invest in doing that. And they are doing that. There's a lot of work going on. As they make more of it, the price of it will come down. But it takes a lot of energy to do that, and so we're encouraging them to carry on that journey. So sustainable aviation fuel is good, but it doesn't take away 100% of the CO2. You still need some energy in terms of making the sustainable aviation fuel, and at the end of the day, you burn that fuel and you put the CO2 back. So with sustainable aviation fuel, you pull the CO2 out of the atmosphere, you make fuel, and then you burn it and you put the CO2 back. The advantage with hydrogen is that the only product from using hydrogen is water. So you don't put any CO2 into the atmosphere when you're actually using it, and you don't produce any other So if we don't produce any NOx, which is something you produce when you burn at high temperatures kerosene, we don't produce any particulates and soots, and we don't produce any contrails. So all of those things we can address with hydrogen. A lot of people are looking at batteries. So if you have a small, but we know that batteries are in use in plenty of cars, and you can apply that technology to very small planes, and people are doing that for like air taxis. But you can't scale batteries up to the sort of plane that Airbus is interested in. There's just not enough. You'd need as much weight of battery as the weight of the plane. So the batteries don't work from the physics, even when we look into the future of the most exciting technology that we can see for batteries today. It will only ever work for very small planes.
Do you ever see nuclear power becoming an option?
I don't think. I have seen back in the sort of 1950s when nuclear power was first being explored, there were people who looked at nuclear onboard aircraft, but I don't think that's an option that we would ever look at today. It's too difficult to do that safely. And safety is a super, super important thing for aviation, as it is for the nuclear industry. But we will need, whether it's sustainable aviation fuel or whether it's hydrogen, and for society in general, we will need a large amount of electricity. And nuclear energy can probably be a big part of the solution to the amount of electricity that we need to generate, and low carbon electricity that we'll be needing in the future, as well as wind farms, as well as solar, as well as all the other sources of low carbon energy. Nuclear can be part of that solution on the ground in order to give us the energy to be able to make sustainable aviation fuel or make hydrogen.
As well as sustainable fuels, what's Airbus doing in terms of using greener materials to make its planes? And can planes be recycled?
Planes can be recycled. The planes, about 80 or 90% of the plane today can be recycled, and there's a very healthy industry in recycling planes and taking all the bits off them and recycling them, because there's a lot of value in those things. So when people can make money out of things, they do. We take very seriously the total life cycle of the plane, and we do life cycle assessments to all of our products. So the amount of material that you use during the manufacturing, we look at that and look at the waste products that come out from the manufacturing process, and also the ability to recycle planes. Sometimes you have to make quite interesting and difficult choices. So we're moving a lot towards composite planes, because that enables us to reduce the weight of the plane, and that enables us to reduce the amount of fuel that they burn. And when you look at the life cycle of a plane, the biggest environmental impact they have is when they're flying, and the amount of CO2 that they are producing, which is why we're so focused on sustainable aviation fuel and hydrogen. So anything that we can do to reduce that, then we really push very hard on that. And one of the things that we can do is composite. But then we have to trade a little bit, because it's really difficult to recycle composites. So some of these questions are actually really tricky.
We ask the big questions here, Andy. And talking of big, we're going to take a quick break to hear some other reasons why Airbus are the giants of the sky. The Airbus A380 is the biggest passenger plane in the world. Get this, its wingspan is longer than a football pitch. That's around 80 metres from tip to tip. You could park 70 cars on just one wing. It's like flying a double-decker with 2 levels for passengers, but just supersized. And then there's the A320. It's the best-selling airliner ever, with over 10,000 already produced. And here's a fun fact. One takes off somewhere in the world every 1.5 seconds. That's faster than you can say, fasten your seatbelts. But probably one of the coolest Airbus planes is the Beluga XL. It's the giant of the skies, with a face like a smiling whale and a belly big enough to carry a whole plane wing. This supersized cargo aircraft is as long as 2 blue whales, hence the name. It's designed to carry massive aircraft parts between Airbus factories across Europe, and does it while looking like it's having a great time too. Now, Science Weekly fans have sent in some aviation questions that they'd like to know more about. First up, what's one of the coolest things you've done working in aviation? I've been really lucky. I've had a long career. One of the things I love about my job
and the coolest thing is the fact that I work for a company that works all around the world. So all of our customers are everywhere in the world, and all of our suppliers are all around the world. So I've been lucky enough to visit very many places all around the world and to work with people in Korea, in China, in Japan, in America, all around Europe. And that for me is one of the most fun parts of my job, is being able to visit those people and work with them and learn about their cultures and learn about them. That's one of the things I find most inspiring about my job, and I think is the coolest thing about what I do, as well as the technology, because what we're designing is pretty cool fundamentally.
All right, what's your favourite plane?
So I would say, well, it obviously is going to be an Airbus airplane, and I've been lucky enough to work on all of the Airbus fleet pretty much. I worked on the A380, so the double-decker plane that you see flying into big airports around the world, and I worked on that plane for 10 years. And that still gives me a thrill. When I'm in an airport and I see people getting up to take photos of the A380, which they still do occasionally, that makes me very proud. And when I took my dad down to the museum in Toulouse, where they've got one of the flight test A380s, and showed him around that, I felt very proud to have worked on it, and he felt very proud of me. So that was really nice. So that's a kind of a favorite thing, because I gave a big chunk of my professional life to making the A380 work. And it's still an aircraft which people look at and go, wow, that's amazing that something so huge and so heavy can fly through the sky.
Next up, as an engineer, what's the most interesting part of a plane for you, and why?
Well, I should say that it's the fuel system, because I've been working on fuel systems for many, many, many years. And fuel systems are amazing. They enable the plane to fly, and they also reduce the weight of the fuel. We move fuel around between the tail and the wings to balance the CG, and we move it within the wings to reduce the loads. But actually, I think the cabin is one of the most amazing things. When you're sat in the cabin, you're really not aware that you are several miles in the air. The outside, the temperature is minus 50. If you went outside and sat on the wing, the wind would be going past at sort of 500 or 600 miles an hour. You wouldn't have enough oxygen to breathe, and you would be dead in a couple of minutes. But you're sitting there as if you're sitting at home, and you're completely comfortable, you're completely warm, you're completely breathing easily. It's quiet these days. You've got all of your entertainment systems are available. You get food, you can go to the loo. It's all there for you.
That's something we've discovered in this series. When we fly a plane, we remember the hustle of the airport and the thrill of takeoff, but then we're just relaxing, watching a movie or looking at the view. We don't really think about the phenomenal amount of engineering all around us.
It's all there for you. And that's quite amazing that we have all of these systems that enable you to do that and not think about the fact that you're actually in a very, very alien environment indeed. But it just seems like you're sitting at home and you can play on your phone or watch a film, and it's just like completely normal. And very soon, I think already, it will be seamless that you'll be perhaps on your phone playing a game, and you'll just walk into the plane and take off and carry on playing your game. And that's where we want to go, that actually being on the plane is totally seamless with being in the airport or being in your house. And we're very close to making that a reality for everyone. So that's kind of amazing. There's lots and lots of things about aircraft that are amazing.
Now, apart from hydrogen, if you were to design the plane of the future, what would you make sure it had or could do?
Well, I think a lot of our focus, I know it's boring to go back to hydrogen. I think the environmental impact is the main focus of what we're working on. It's always been the focus. Reducing fuel burn has always been the focus, because actually fuel is a huge part of the cost of our customers. We sell planes to airlines. They want to make some money, and they have to buy the fuel. So we've always been focused on reducing that. And of course, that's always had the benefit that we're constantly reducing the CO2. So that will be our number one concern. Beyond safety, which is absolutely paramount in everything we do. We want you to be super, super, super safe, and you are when you're on board an aircraft. But the environmental impact will be our next focus. And I'd love to get to the point where basically you have no environmental impact at all. It's very tricky to get to zero. but we can get really, really close in the future. And I think that would be an amazing thing to be able to achieve.
Time for one of my favourite questions. Any bizarre aviation facts? Something that would just make us go, wow?
I think, so from my experience on 380, one of the things I love is, so one of the things we did with A380, it's a huge plane. It carries 250 tons of fuel. It was capable of doing that. So we had to be able to refuel it really quickly. So if you refuel an A380 at the maximum rate it can do, you can upload 8,000 litres of fuel in a minute. And if you did that to your car, it would be all over in about half a second at that rate. So you could refuel a family car in half a second at the rate we would do an A380. But my favourite fact about the A380 is the brakes. And I used to be working on the landing gear of the 380 as well. So the brakes on the A380 are capable of stopping it in a rejected takeoff. So you're about to take off, and then the pilot realizes there's something wrong, and he has to slam on the brakes and stop the plane in the on the runway. That's a really tough test that we do as part of the certification. The energy that is absorbed by the brakes during that process is equivalent to 2,500 family cars doing an emergency stop on the motorway. So the brakes on an A380 or any aircraft are incredible, the amount of energy that they can take. So one A380 is equivalent to 2,500 family cars in terms of the brake capacity.
Whoa, I mean, that is crazy. And how amazing to get to work with this cool technology. In fact, we've been looking at some of the cool jobs in aviation, and here's one our audience might not know about. The people who give these amazing aircraft the finishing touches. Let's check it out with the aircraft painters. You've no doubt seen the huge variety of paint colours and designs that planes have, but have you ever wondered how planes get painted? Well, it's all done by specialist aircraft paint technicians working in large climate-controlled hangars. When repainting an old plane, the first job is to remove the old paint. This is done by sanding or using special chemicals, and it helps reduce weight, as each layer of paint could weigh up to 500 kilograms. The aircraft is then cleaned and inspected for any damage. A protective primer is applied, followed by several layers of lightweight weather-resistant paint using spray guns and stencils for a smooth finish, and this includes the airline's colours and logos. It can take up to 2 weeks to fully repaint a large aircraft. Aircraft painter is a brilliant job for people who enjoy practical, hands-on work and want to help aircraft look amazing while staying efficient and airworthy. I like to think I was quite good at art at school, so I reckon I'd be good at that. Anyway, back to our guest Andy at Airbus. How about you? Could you outline your career path?
So I started a very, very long time ago. I've been working for Airbus for more than 30 years, which seems crazy to say. I started off as an apprentice, so I left school having done my A-levels, having studied maths and physics and chemistry, and I came and joined Airbus, and I worked on the shop floor for a year in overalls, drilling holes in things, and that was really cool, actually, to spend some time in that environment learning actually how planes are built. And then I went to university for 4 years. I came back and worked each summer in different areas, and then after that I kind of got a real job. And I joined the fuel department. And after a few years, I was working on the A380. I was really lucky that I joined that department just a few years before the A380 was launched. And so I managed to join that incredible project right at the start and see it through. So I spent the time from my late 20s to my sort of late 30s working on the A380 and other fuel systems, and built that plane and saw it go, saw the first flight, saw it enter service. Then I worked in the Sharklets. So I was in charge of the Sharklets. So if you see an A320 and it's got the wings turned up at the end, so like the wings that stick up to the skies, I was in charge of the team that was designing and building those, which was really cool because those are built in Korea. So I spent 3 years going back and forth to Korea to build a factory out there, design those, test those, certify them, put them into service. Then I worked on the A350 for quite a few years. I ended up as the local chief engineer in the UK. So the chief engineer for all of the things that are done on the A350 in the UK. And then I became in charge of all the chief engineers for Airbus for a while. and now I'm looking at hydrogen. So it's been an amazing career. I have enjoyed many aspects of it enormously. It's been really incredible. I've had lots and lots of opportunities to be involved in some really cool technology. But as I say, it's a global industry where you're meeting people from all over the world and helping them work together to do things. You're meeting airlines. I'm having to go out to airlines and explain how the plane is working or not working. Sometimes you're getting shouted at because the plane is not working and it's your fault. And that's also actually really exciting. It's not nice to be shouted at, but you can make a real difference and you're working directly with the customers, and that's really interesting. So it's been a very, very exciting and interesting journey for me for a long period of time, and I've done lots of things. And most of the engineers, in fact, all the engineers now pretty much got master's degrees. So they've studied maths and sciences through their A-levels, and then they've gone to university. A lot of them do apprenticeships. I did an apprenticeship, and I think that's a really cool way. So then you're probably closely working with a company and also doing your degree at the same time. That's a really fantastic way of joining a company. And I certainly recommend that. Airbus has got great apprenticeship opportunities, and we bring a lot of people in through that route, and it's really cool. Or you can join after you've got a degree as an engineer. But Airbus is a huge, huge company. It's got more than 100,000 people working all around the world. Some of them are doing engineering, but many of them are not. They're doing manufacturing, so they're actually physically making things, and we still employ thousands of people in the UK making things, and all around Europe and all around the world. And we've got lots of other industries. We've got people who look after our comms, as we saw today. We've got lawyers, we've got marketing people, we've got a lot of financial people, we've got project managers. We've got basically every type of career, barring doctors and nurses. We don't have a lot of them. But many, many, many types of careers in Airbus. Not all of those need degrees.
When you were a kid, were there any clues that you might end up in your career?
Well, I did study maths, and I did study physics and chemistry, and I enjoyed those. I loved Lego when I was a kid, and I loved kind of investigating things. I think if you're going to be an engineer, you need to be curious about things. You need to want to know how things work. I did a lot of DIY. I spent a lot of time. I was very lucky. My grandfather in particular loved doing DIY, and I helped him and my dad doing that. So working with your hands, doing practical things. I think perhaps there were some clues there. I grew up in Bristol, which is actually where I live now, and the Concorde factory was just which is where we work today. So Concorde was built here in Filton, where we are today. So that we used to fly over my school when I was at school. So there was a very close link between aviation. But it is a bit of I applied to do lots of different engineering jobs, and aviation is super cool, but engineering as a whole is super cool. And there's so many different types of engineering. You don't have to be involved in planes. You can be involved in buildings and bridges and dams, or we're talking to each other on my phone and your computer. Engineers are involved in all of the parts of making that work. So many parts of our life today relies on engineers being able to solve problems and solve them in a way that you don't notice you're using them. You just use the phone and it works. And you don't think of all the very, very clever people who've worked in the background to make it work. You go and make yourself a cup of tea. You go to the loo. All of those things require engineers to solve problems and make it work so that you don't have to worry about it. And it just happens. And lots of that is super, super interesting. And we need curious minds to work out how to make it better for the future.
And finally, any words of guidance that you would give to children considering a career in aviation?
I would say get involved if you can. If you're really passionate about aviation, then get involved in doing it. See if you can get involved in opportunities to fly, maybe to gliding or things like that. There are things that you can do as a kid to get involved in that, and that's amazing. Not everyone has that opportunity, but if you can, it's really cool. Be curious about it and go and investigate. And I think if you want to be an aerospace engineer, then you're going to need to be passionate about maths and physics. those are the building blocks that we use in order to understand the world and be able to sort of describe it and then control it and put the systems in place. So I'd say explore it and understand it, and if you can, get involved with it. But if you want to be involved as an engineer, then you need to be studying those things, and you need to be excited by those things, because I think maths and physics and chemistry and all that, they are really interesting once you're able to use them and understand them. But I would say aviation is amazing. Go and spend time with it, and if you have the opportunity to actually get involved, then do that.
Thanks, Andy. And with all that, it's time for us to head to departures. But I hope that you can join us again soon. Fun Kids Science Weekly Reach for the Sky special, created with support from a CAA Reach for the Sky Challenge grant. Find out more at funkidslive.com.